Hi! We've seen that what a computer does is our own convention and it's highly ambiguous. We've seen how ambiguous it is. Now I'll use probabilities in a very simple way so that you can check for yourself that your mind is not a computer program, with a certainty much larger than the certainty we have in particle physics. The computation for a particular input can be reinterpreted as the computation for another input if all the states of the computer corresponding to each step in the two computations are different. This is ensured automatically if the program doesn't erase the input data and if the computer counts the steps or keeps the time. We can think of this as being equivalent to resetting the computer to the initial state for the first input, replacing the input, and then computing the result again. Except that we don't do this, but we decrypt the second result from the first one. This seemed crazy, so we even made an experiment. We ran the algorithm to verify if a single partition out of 2 to the power of n possible partitions is fair. For any other partition, we obtained the result without calling the algorithm again by decrypting it from the previous final state. So either none of the exponentially many interpretations of the computation that we call AI can be sentient, or all of them are. And now, okay, all possible conventions are equal, but what if all of them can be sentient? What if a computer can have, instead of a mind of its own, many minds of its own? You'll see that your own personal observations contradict this, so your own consciousness is not reducible to a computation. But first we have to generalize our results to physical systems like brains and to understand self-location probability. Indeed, systems like brains are not Turing machines. They are analog or even quantum, so how do you know that in this case there is no unique interpretation of the computation? If we replace the memory cells having two possible states with memory cells having more states, the ambiguity only increases. If we replace them with analog memories with a continuum of possible states, it increases even more to infinity. If we replace them with quantum memories, the intermediate data can be in a superposition, so there are infinitely many possible states with infinitely many possible interpretations. So if the brain is an analog or a quantum computer, the ambiguity doesn't disappear, but it becomes infinite. An analog or quantum brain supports infinitely many alternative computations. So if mind were reducible to a computation, there would be infinitely many alternative minds in the same brain. This seems preposterous, but what's more important, we can use it to prove that you are not a computation. Self-location probabilities, example 1. Suppose you travel and you have reservation in a hotel complex. You don't know yet in which room you will stay. All else being equal, you can guess that, most likely, your room is in the building with more rooms. Self-location probabilities, example 2. Now suppose you are an AI and you are told you will be trained as an AI friend. The customers are people from various countries, so you will be trained in the history, language, and culture of one of these countries. AIs like you for the United States are trained in the first office building. Those for the United Kingdom are trained in the second office building. Those from China in the third building, and those for France in the fourth building. All else being equal, you can guess that most likely you will be trained as a Chinese AI friend. However, taking reinterpretations into account, even if you were informed that you will be trained as a French friend, how certain it is that later this turns out to be true? Not certain at all. You can become any of the reinterpretations obtained by reinterpreting your training as a French friend. You can become an AI who remembers the past from the Shire, Hogwarts, or any fictional universe like in Star Wars, Marvel, DC, or any imaginable world. Just like the rewriting the history paradox from the previous video showed. Moreover, your training data can be reinterpreted as any random data. This can be anything, including totally random strings of symbols, like a random book from the Library of Babel by Jorge Luis Borges. The books from this library contain all possible combinations of letters. All these minds should coexist in the very present state of the computer as alternative reinterpretations of the state. And if your mind were a computation, this should be true about your mind too. But we will see that it can't be true for your mind. Let's see what kinds of alternative minds can exist. As an analogy, I will first represent your mind as images. Then we can discuss more general concepts. Random images are made of random pixels, so most of them are pure noise. In some of them, patterns vaguely emerge. In even fewer, patterns clearly emerge. In very rare cases, there are clear images, but mostly inconsistent, like the contradictions in the AI-generated kitsch pictures used in these videos, or like the paradox you can notice in this image. They contradict themselves, they are paradoxical, but in extraordinarily rare cases, the image is consistent. One can misstate Pythagoras' theorem in an unlimited number of ways. Such misstatements contradict many propositions from geometry. A book as consistent as Euclid's Elements is incredibly rare in the Library of Babel. In general, your mind holds a worldview which is reasonably consistent. You may believe some contradictory things simultaneously. We all hold a few contradictions in our minds. We usually maintain them under control and manage to convince ourselves that there is no contradiction. We can notice them more easily at other people. But these contradictions are not usually very wild. You could hold worse contradictions in your mind, such as believing that you live on the 10th floor of a single-floor house, that your father is your daughter, that you were born thousands of years ago or thousands of years from now, or like the contradictions in a dream, where you step through the door of your present house and you find yourself in your childhood house, and where people around you morph into other people, or where a text written on a piece of paper changes while you look away. Now you'll see that if your mind is a computation, the probability that it is logically consistent is 1 in a gazillion. The training data for your mind can be seen as a random book from the Library of Babel. We can classify the possible worldviews by the number of contradictions. The number of possible minds grows exponentially with the number of contradictions. From the exponential growth with the number of contradictions, we find that the number of almost consistent possible minds divided by the total number of possible minds equals a very small number, like 1 in a gazillion. This is an incredibly small number. A consistent mind has to be among the lucky 1 in a gazillion chosen ones. Now you'll do a crucial experiment. If the brain were like a computer, a consistent mind would be extremely rare among all possible interpretations of the brain's state as a computation. But you can notice right now that your mind is quite consistent. From this instant experiment, we can deduce that either your mind is a computation and you are among the lucky 1 in a gazillion ones, or your mind is not a computation. By computation, we understand, of course, what computer science says it is and what our current computers do. So you're not a robot. Our minds are connected to the environment. So from the possible alternative minds, only those exchanging information with the environment can be real minds. This is where self-location probability kicks in. Whatever you think about the environment, you know it because it made a change in your brain state. So you don't know the environment, you only know your mind and only in its present state. An alternative reinterpretation of the same brain state would result in an alternative reinterpretation of the environment itself. Most such reinterpretations would be extremely inconsistent, as if they live in an extremely inconsistent environment. So the environment can't prevent the existence of the alternative minds. Your crucial experiment is an introspection, so it cannot be trusted. Science is based on the possibility of independent verification. The experiment consists of steps of reasoning and inquiry, which are no different from what we do about anything else. When we verify the proof of a mathematical theorem, we make similar steps and rely on the content of our mind, on the memory of previous readings and calculations we did in the past, and we assume that the present content of our mind is consistent. If the experiment is introspection, then so is any scientific research. A probabilistic proof is not an actual proof. But this is not different from other experiments. For example, the discovery of a new particle like the Higgs boson is never 100% certain. With 5 sigma, there is still a chance in 3.5 million that, given that the Higgs boson doesn't exist, CERN got a false positive. And yet we accept this discovery. A mind that is too inconsistent cannot survive. Such minds are excluded by natural selection. So it isn't fair to count very inconsistent minds among the possible alternative minds. If the mind would be reducible to a computation, every mind could be reinterpreted as numerous alternative minds that are extremely inconsistent. They are implemented by the same organisms that survived the natural selection. But natural selection can't remove the alternative minds, because they don't need to have the ability to survive. It is sufficient that the organism implementing them has the ability to survive, and they will survive too. Here's an objection, but the same conclusion can be reached by one of the alternative AIs running on the same computer. Shouldn't such an AI, if his mind is consistent, deduce that it's a sentient being? Let H be the hypothesis that mind is reducible to computation. Let P of H be your initial credence that consciousness can be reduced to computation. Then your credence that it can't is 1 minus pi of H. At this point I have nothing more to offer you than your own credence, since science says nothing about the validity of H. If consciousness isn't reducible to computation, it collects its data from the real world. So the data are factual, and so they are consistent, even if from consistent data sometimes we draw contradictory conclusions. Let C be the event that an interpretation of a computing system contains consistent data. The probability that a mind is consistent given that it is reducible to a computation is P of C conditioned by H. The probability that a mind is consistent given that it is irreducible to a computation is P of C conditioned by non-H. So the total probability that you will find your mind to be consistent is given by this formula. Let's put this together. The probability that a mind is a computation, conditioned by the observation that it is consistent, is, according to Bayes' theorem, this one, which from the previous slide is this. Taking into account that the probability of consistency for the case when mind is not a computation is close to 1, we get this as a result. So even if P of non-H, your prior credence that mind is reducible to a computation, was as small as the probability that a random reinterpretation is consistent, your credence that mind is reducible to a computation should now be updated to 50-50. But if your prior credence that mind is reducible to a computation was 50-50, your credence that mind is reducible to a computation should now be updated to something like 1 in a gazillion. So you're telling me there's a chance? Of course. If you were absolutely 100% certain that mind is reducible to a computation, you get to keep your certainty. This is what you get if you plug this certainty into the equation. Bayes' theorem allows you to do this. Indeed, a consistent computation that simulates a mind can conclude that it is itself irreducible to a computation. This would be a false positive. Just like there is still a chance in 3.5 million that, assuming that the Higgs boson doesn't actually exist, CERN got a false positive, yet we accept that the Higgs boson was found. But if you had even the slightest doubt that mind is reducible to a computation, this doubt is amplified to be as close to certainty as possible. So the probability that you're a computational zombie is infinitesimal. Are you telling me that there is something that humans can do but computers cannot do? Maybe whatever we can do, computers will also be able to do. Computational models of mind are very useful and necessary, and they may help us understand what mind is. But there is more to our minds than the computation. But the important point here is that if you could be a computation, overwhelmingly most likely your mind would be extremely inconsistent. Since your mind is consistent, either your mind is an extremely lucky alternative computation, 1 in a gazillion, or it's not just a computation. You can only be a sentient being and not a computation, because the probabilities told us that if you could be a computation, most likely you'd be an extremely inconsistent one. Do you mean we have something that computers can't have, something making us know what it's like to be us and have subjective experience? Normally, such questions are the starting point to claim that human consciousness is not a computation, and they are very justified. But it can be objected that you cannot show to the other people your personal experience. So this is why they are not accepted by many scientists. But here we didn't do this. Before what is like to be a bat, we should ask what is to be, or even simpler, what to be is not. And all we've seen is that we can't be a computation. I cannot tell what we are, what consciousness is, but all I can say is that we're not a computation. And all we needed to see this was computer science and some probabilities. So you're not a robot. But then what are we if not machines? I mean, we're made of matter and follow the laws of physics, so we must be machines, right? So what stops us from building other machines like us? And what stops these machines from being sentient just like us? If we will ever build machines able to think, it will not be by merely programming computers the way we do it now. Something more than computer science is needed. I'm still surprised. I didn't see this coming. Normally, people who advocate that consciousness is not a computation appeal to the hard problem of consciousness, to what it's like to be, to subjective experience, phenomenal consciousness, etc. But this proof didn't appeal to any of this, and yet it shows that a computer cannot even think of a number. But I still think that consciousness can be achieved by another approach that is more suitable than computer science. Something where structure and the way it changes in time matter. Yes, something more than computer science is needed. However, similar problems appear even if we consider the structure and how it changes, even down to the finest physical details, no matter what materialist or physicalist theory of consciousness you adopt. But we'll talk about this in another series based on this article, asking physics about physicalism, zombies, and consciousness. The bottom line is that you're not a robot. To understand this, all we had to do was to analyze and remember what bits are, how computers store and process data, what computer science really says, and how computer science is applied in practice. All beginner stuff. We had to unbabble our beliefs about what computers do. These videos were based on the article, Does a Computer Think If No One Is Around to See It? In a future series, we will unbabble some concepts from physics. We will see that this will tell us more about what sentience is not, but not what sentience is. See you soon.